It's the space station. Several things going on there of interest. One is figuring out what to do with it. It's near the end of life, but it's not there yet. And there's been actually quite a bit of controversy over just what to do. NASA did just award SpaceX a contract for basically a tug to deorbit the space station. And that's like $843 million. That doesn't include launching the tug. So that's going to be a separate contract. The whole thing will be like $1.5 million. They haven't actually said even what they'll use. I mean, everybody would assume it's going to be a Falcon Heavy. Apparently, it's too big to do this on just a regular Falcon 9 like you might expect. So that contract hasn't been let yet. But what they're going to do to accomplish this tug is essentially they're going to take an existing design, which is the Cargo Dragon, which is what takes cargo to the space station now. And it kind of makes sense that either SpaceX or Northrop Grumman were about the only two people that bid on this, because they're the ones that know how to do the docking and all these kind of things that really nobody else would have any experience with. So it came down to just a few people. But so the Dragon was going to be likely part of this. What they're going to do is take the trunk part of it, which is normally where there's just engines and a little bit of fuel, make it a whole lot bigger. Put a whole lot more fuel in there, a whole lot more thrusters. So instead of having 16 engines, they're going to have 46. 16 is a normal component, and 35,000 pounds of propellant. So it goes way beyond what the normal cargo would be for going up there. The plan is it would dock way before we're actually going to do the deorbiting, and gradually operations would wind down. It'll stay there docked for 18 months, and the orbit will continue to decay. It always is decaying because there are a few air molecules up there even at that altitude. And so it gradually decays, and then they're going to do some final burns after 18 months. And the intention is it will come down, a lot of it will vaporize, certainly the small parts like solar arrays and that sort of thing. Big heavy parts will end up being dropped in the ocean. So of course they're going to try to do this to aim for the ocean. It'll be probably a 1,000-mile stretch in the ocean. Typically they do this over the Pacific. There's kind of a standard spot where they do this kind of thing. That's not unusual. It's just never been done on anything of this scale before. I mean, the thing does weigh 990,000 pounds. A lot of people really don't like this very much. There's been a fight. This has been going on for years. It's not new, but it's getting louder and louder now that it's starting to actually happen. Contracts are being let. So you could have a garage sale and have parts. They're still putting new stuff up there. You know, one would think that they could reuse some of that stuff. We had somebody here from Axiom Space, which is tying in, and I suggested that they could do some midnight raids, surely. Near the end of life, they're going to be attached to the space station. Surely they can just kind of sneak in there and grab some of that stuff, because otherwise it's just going to get burned up anyway. So one would hope that at least some of that will get reused. There are a lot of people that think it ought to be a museum. Just keep the thing around. You know, it is a major part of our history, and in particular the history of space exploration. One way to look at it, I think, for the future, we're not ready to do this yet, but in the future you'd like to have kind of a circular economy going on up there, where things that go to space stay in space, rather than just coming back and essentially polluting the atmosphere with aluminum and titanium ions. You know, keep it up there, because it still costs a lot of money to raise stuff up. Even with Starship coming along, lowering costs, it's not free to put stuff up there, and you've got that much stuff. It makes more sense to have foundries. You know, you can just melt down. It's mostly aluminum. You can melt a lot of that stuff down and build new structures, like things supporting solar panels for space-based solar power, that kind of thing. The problem is we don't have the technology really to do that yet, so it's a little premature. But people have said, well, okay, take the same thrust, and instead of using it to slow down the orbit and drop the thing in the ocean, raise it up. It's about 400 kilometers now. Take it up to 800 kilometers, where you can have a stable orbit where it would last for a long time. So those kind of arguments are still going on, but of course in the meantime, SpaceX will start working on producing this thing. One big problem really that's lurking behind all of this is simply that if you try to save the space station, what happens when things go wrong? Parts fall off, satellites get destroyed, that kind of thing. Who's going to pay for that? And when you get right down to it, liability, especially in America, but really anywhere, it actually makes it so terrifying, I think, to NASA or anybody else, that probably that may actually be the thing that really dominates. That probably will keep them from doing anything other than just dumping it in the ocean.
Well, you're in space.
Yeah. Well, you know, we always said, when we go to space, you know, people used to think of astronauts as being all you needed to go to space, but really every job on Earth has a counterpart in space someday. And that as that time goes on, there will be people. There's going to be people that are going to be doing mining of asteroids. There's going to be people running foundries to melt down old aluminum and steel and make new things. And there's going to be people doing agriculture, all these things. Yeah.
Has anybody made any calculations on what it would cost to manage it if they pushed it into outer orbit?
Probably. I don't know those numbers, though. But
well,
I'm sure that the people at NASA that want to dump the thing have come up with very large numbers. And the people like Rick Tumlinson that want to save it probably come up with very different numbers because you make assumptions, and that's a typical problem with any of these studies is that really people have a solution in mind a lot of times. And if they want it to look expensive, they can make it look expensive. If they want it to be cheap, they'll make it cheap. It's really unknown because you don't know how well it's going to hold together. People always said, well, you can't really push the orbit up higher because the whole thing will fall apart. Well, if that's true, the same is true when you slow it down. Either way, you're applying the same amount of force. So, I would take all of those estimates with a grain of salt. Okay, now the other big story, of course, coming out of the space station is tied in with Boeing and its Starliner. And I think everybody has probably heard of this one. The Starliner, as a test flight, took up 2 astronauts to the space station. They had some trouble along the way and a little bit of trouble getting in, but they finally got it there. But there was a lot of concern because the thrusters, the small ones that are used for making adjustments to come in, for instance, to dock, or any kind of positioning in general, they had problems. Several problems came up. One was the thrusters themselves. Another was the software associated with it. There are also problems with helium, which is providing the pressure to keep all this stuff going. They had seals that had degraded. And so they're trying to figure out, well, what really are exactly the problems and what are the root causes of them? And they wanted to do this. They wanted to learn all this. They have to do it while the thing is still there. And the problem is that all these thrusters and systems, they're all in the Starliner. And that, when that goes back down, what's called the service module gets vaporized. It's only really a small cabin left for the astronauts that would get saved. So any of the evidence for what happened would be destroyed. And so, of course, they want to hang on. That's been the official story, and it does make sense. You want to do the troubleshooting. But it's now gone on quite a while. So the main issues here are there's really not a really definitive root cause analysis of all the problems. I mean, they've identified some. It's not clear why some of it's happening. There's a theory that the thrusters are getting hotter than they were designed to. Maybe they didn't design adequate cooling for them or something. And there's some valves that let in the fuel and the oxidant. And there's seals. There's Teflon seals on this. And apparently they found that they've gotten kind of extruded and they may be restricting the flow. Things aren't really working the way they're supposed to. That's still kind of working theory. It's not 100% definitive. And that's what makes everybody so uncomfortable, is they're not quite sure what's going on. So the question is, what are they going to do about it? So there's several possibilities. One is to just put the astronauts, 2 astronauts, back on that same Starliner, send it back and hope for the best. I mean, that's one thing. But of course, that makes everyone nervous. Another approach is, well, the next mission going up, which will be on a Falcon 9 with the Crew Dragon on top of it, take that up and just leave 2 empty seats. You normally take 4 people, but just take 2. And then when that returns in February, which would be the normal cycle for that, go ahead and bring them back at that point. Now, there is some problem here, because that assumption says that you have to then undock the Starliner automatically. Now, they've proven they can do that in the previous test a couple of years ago. However, they apparently removed all that software because they said, well, this is a crewed mission. We assume there's going to be a crew on there, and which was true, of course. They did have a crew. Now, what they have to do, even if you want to just throw the Starliner away, just let the thing vaporize in the atmosphere, you have to get it away from the station safely without crashing into it. That's a concern. So they don't have the software to do it. For some reason, it's going to take weeks. Now, obviously, an upload doesn't necessarily take that long. However, the testing for it, to really make sure that it's really right, because it hasn't been used in a couple of years, they say, you're talking a couple of weeks. So you need that if you want to just even use a Crew Dragon to rescue them. And it's worse, though. If you take the 2 astronauts and you put them back on the Starliner and send that back to Earth, what they found was apparently the stress of manual control went beyond the normal limits that those thrusters were designed for. So that actually they think that's partly what has caused them damage. So they're actually kind of afraid to do that. They said that even if you put the astronauts on the Starliner and you want to go away, you better do that under automatic control, not manual control. And so to do that, you need that software. So either way, they have to do the software. And some people have suggested, well, that's one of the reasons they've delayed the next flight up to the ISS with Crew anyway, just to make sure they can get the new software in there and test it. So yeah, people are saying the astronauts are stranded, and it's kind of looking more and more like that's an appropriate word. There's no imminent danger. They have plenty of supplies to last for quite a while, and they still can bring in cargo. But anyway, it's sort of a mess right now, but nobody's quite sure just what to do.
Just briefly, the software to bring back the vehicle automatically without a crew, they didn't put that on as a plan B.
Yeah,
That's kind of almost indefensible.
I think Boeing is just not any good with software. We've seen that with planes and everything else. They're not good at designing systems that are run by software, period, and having a user interface for it.
Okay. We have a note in chat, Mr. Vaughn, that it sounds like the problem might not be the software, but a configuration file that needs to be updated.
Well, that's true, and that doesn't necessarily take that long, but they still have to do the testing. The real issue is testing, because it probably won't be exactly the same set of parameters they might have used a couple of years ago, and so if there's any differences at all, they're going to end up wanting to test that. Most of the time is going to be in the testing. The thing is, anything these days is usually a mixture of some automation and some manual operations, and you almost always want to have one or the other available, or both available as a choice. Yeah, I mean, the idea that they just kind of completely removed a basic capability is just, in any case, they just don't seem to know how to manage it.
Robin asked unbiased estimate of the cost to keep the ISS up.
I don't know who has that estimate. Mostly they're talking concepts, and yeah, who would you trust? It's one of those things where it's gotten so emotional that I'm not sure I trust anybody's estimates. They're going to be so slanted based on the conclusion they want to reach. You're talking about risk, and that's why it's hard to quantify anyway. Part of it's risk. Will the thing break apart? Will it hit other stuff on the way? What happens if it does? And that's where you get into things where you're estimating probabilities for things that don't normally happen. You don't have good ways of estimating any of that stuff. So that's why people can make up all the scenarios. You have to make up some assumption, if you're going to make an estimate of cost. And it's all based on stuff that is unknowable. So.
Life insurance, we're just all
Actuaries.
I'm 35% confident of this now.
Yeah, well, that's the thing, is actuaries have data to work on. They can look at, deaths and sicknesses and everything, and they have those statistics for 100 years. We don't have any statistics on any of this stuff. Okay, that's it. Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.